In this example, we want to find an area inside two curves again, but it's the area that's common. So we want area that's common to the 4-petal rows cosine 2 theta, so that's this guy here, and the circle r equals 1/2, which is this guy here. So this is r equals cos 2 theta. And then this is r equal 1/2. So the region that we want to find is inside here. It's inside the circle and it's inside the 4-leaf rows. So we've got a lot of pieces that look similar there. So we want that, all these. So notice that we've got x-axis and y-axis symmetry here. So we actually can just find the area of one piece, this piece right here, and then multiply by 8. Because there's 8 pieces that are identical in size. So well, let's take a second here and enlarge this little piece so we can get a little bit better picture of it. So this right here is this, that's the circle. So this is r equal 1/2. And then this piece up here and this right here, those are these guys here. That's part of r equal cos 2 theta. So, and we want this region here. So, well, let's sweep a segment over this region, see what that looks like. So we're going to start here at 0, and we're going to sweep over the region, so it's adding up the little sectors of pi like this. And then the radius is 1/2 at that point. But then here, when it sweeps over the rest of the region, it's touching on r equal cos 2 theta. So we've got 2 different radii, but only one gets used at a time. It's not outer squared minus inner squared. It's a little bit different. But also notice it changes at this point of intersection, which is where that angle is. And then also notice here that your segment that sweeps over the remainder of this region, it starts at this angle here of intersection, but then it ends actually at this angle here, which is this one. And that looks like the 45-degree angle, and because of all of our symmetry, x and y axis, yeah, that is the 45-degree angle. So that's pi over 4. So that's this guy, pi over 4. So now we need to know, what is this angle? Well, that's a point of intersection of the curves r equal 1/2 and cosine 2 theta. So we can just set cosine 2 theta equal to 1/2. And then if you go to your unit circle, cosine is 1/2 at pi over 3 and 5 pi over 3, or pi over 3 and negative pi over 3. So that means that this angle 2 theta in here has got to be plus or minus pi over 3. Multiply both sides by 1/2. And theta is plus or minus pi over 6. So this is pi over 6. So now we're ready to go ahead and set up the integral. So first, we've got 2 different areas. So let's call this area 1. And then let's call this guy area 2. So our first integral will be to find area 1 right here. So we're going to add up our slices from 0 to pi over 6. So remember the limiting positions of your radial segment. So starts at 0, ends at pi over 6. That's sweeping the circle. So those are these limits here. And then the next limits are pi over 6 to pi over 4 as it sweeps the cosine 2 theta. Okay, and that's right here, pi over 6 to pi over 4. So let's consider area 1 first. So if we draw a general radial segment there, the endpoint of that segment is on r equals 1/2. So we're going to integrate, remember our area formula is the integral of 1/2 r squared d theta. So 0 to pi over 6, 1/2, and our radius is also 1/2. And then integral from pi over 6 to pi over 4, our radius is cosine 2 theta. So if we draw a general radial segment in that region, looks like this. The endpoint gives the radius or the length of the segment, which is cos 2 theta. This is 1/2. So our second integral, pi over 6 to pi over 4, 1/2 r squared. Our radius is cos 2 theta. So cosine 2 theta squared. So, and then we'll go ahead and evaluate this. So this area here is area 1. Let's just notice that. This is area 1. And this integral represents area 2. Okay, let's go back up. So area 1, inside the circle. Area 2, this little sliver that's inside the cosine 2 theta, but not hitting on the circle. So then we take area 1 plus area 2, we add them up, and then multiply by 8. That's their symmetry. So that's where those came from. So let's go ahead and work on these. So I noticed I got a common factor of 1/2 here. I pulled it out in front and canceled it into the 8 to get 4. So pulled that guy out and pulled this guy out. And then my 1/2 squared is still left here. The 1/2 got taken out. I'm still left with cosine 2 theta squared. It's a cosine squared. Well, this 1/4, actually I'm going to multiply this 4 in. And then the 1/4 I'm going to bring out in front of the integral here. So that 4 right there is here. And then this 1/4 is the 1/2 squared. Those cancel. We got integral 0 to pi over 6. The only thing that's left in here is 1 d theta. Well, that's an easy integral. That works out nice. And then this one, we pulled the 1/2 out, so we've got cosine 2 theta left squared. So we're going to trade a square for twice the angle. So it's half angle formula. So this will be 1/2 times 1 plus cosine 4 theta. Okay, half angle, you get rid of the square, because this square I could have written right there, cosine squared 2 theta. You get rid of the square by doubling the angle. So then 1/2 goes into 4, leaves me a 2 there. So now I've got just the antiderivative of 1, which is theta, 0 to pi over 6. And then I've got the 2 outside here, and 1 plus cosine 4 theta left on the inside. So here, plug in pi over 6, plug in 0 and subtract, we get pi over 6. Here we've got to integrate. So we got that 2 outside here. Antiderivative of 1 is theta, plus antiderivative cosine 4 theta is sine 4 theta, and then multiply by 1/4. So divide by 4 instead of multiplying by 4. And that's going from pi over 6 to pi over 4. So plug pi over 6 in. Plug pi over 4 in. That's right here. So pi over 4, 1/4 sine 4 pi over 4 is pi. And then plug your pi over 6 in here and in here. So 4 times pi over 6 is 2 pi over 3. So now sine of pi is actually equal to 0. So that term drops out. And then sine of 2 pi over 3, that is root 3 over 2. So now we just got the pi over 4 minus 0, and then 1/4 times root 3 over 2 is root 3 over 8 here. So we don't need the 0. Remove all the parentheses so that the sign distributes negative pi over 6 and negative root 3 over 8. And then that gets multiplied by 2. So this pi over 6 is right here. 2 times pi over 4, pi over 2 there. 2 times pi over 6, so I'm doing this. 2 times pi over 6 negative is negative pi over 3. 2 times root 3 over 8 is root 3 over 4, and the minus sign distributes. And then these guys, if you get a common denominator, well, if you get a common denominator and combine these, you just get pi over 3. So pi over 3 minus root 3 over 4. So quite a bit of work there to get to that one answer. But you wouldn't even have to simplify, if you were doing this for me on exam, you could have stopped like right here. That would have been fine. So with that example, try WebAssign section 10.4, problems 4 and 5 should have an outer radius that switches.